Welcome back to Auto Keyword in C++. This is a part two, and we're focusing on when not to use auto, or when auto produce the undesired result, right? Or what you be aware. So the first thing, um, we should be aware of using auto when we use it with curly braces. In modern C++, beginning in C++11, we can initialize variables using the curly braces. Here, for example, we use uh, variables x and y, and we can initialize the variable inside the curly braces. We give the value, and we're gonna see what type that auto will return. Another case is auto will reduce the type to the undefined one when we use with the proxy classes. So particularly in the standard library, where, for example, we have a class vector or smart pointers, shared pointer, or unique pointer. Inside these classes, they have the proxy class, which when applied to auto will return an unwanted type. So we can look into that more detail. The first thing, when we're using auto with curly braces, you can see, okay, what's the effect? Here we have example X, Y, and Z. We can initialize these variable using auto. So X and Y uh, result in the similar behavior in that auto will return when using the initializing with curly braces the type of initializer list. Inside the curly braces of X, we have the integer, which is 99, that will return the initializer list of int. Also, Y, you have initializer list of type double. We cannot initialize in Z and will produce error because the type inside curly braces are inconsistent. 1 and 2 are integer, but 3 is double. So you cannot deduce using auto and produce error. And also the user should be aware when use auto with function return type. If it's returned curly braces, this will cause error as this cannot deduce. Right? So to summarize, be aware of using with curly braces of the type return. The next case, when we use auto with the proxy classes. So what is proxy class? A proxy class is a class to emulate and augment the behavior of some other type. I will show you in this particular example. If we want to get the sensor status for a particular encoder, here we pay attention to encoder 3, right? When we want the status of the encoder 3, we can write it like this. Sensor status functions will return the range of different encoder status. And if you want a particular encoder, we can write like the index, and the index of 3 will retrieve the status of encoder 3. Here, we apply the return of sensor status as the vector of Boolean. This will return as usual the vector of Boolean. But what is unusual is that we apply the operator braces like this. And this one, when used with the vector of Boolean, will return the type vector Boolean of reference. This is the reference of the encoder 3, right? And this is a proxy class. It's a class that emulate the reference, right? So what is the undesired behavior that sensor says is a temporary object, and this expression return the reference to the temporary object, and although will deduce the reference to temporary object and cause the dangling pointer. If we have the sensor on as a dangling pointer, when we take this variable as a parameter to other functions, this will cause an undefined behavior. And we don't want it. So be aware when we use auto with proxy class. In this case, the proxy class is a class reference inside the vector itself. So how do we know which class has a proxy class? Or how should we do? We can like study the header file of standard library and see, okay, we have the proxy class or not. But that's not effective, right? Or we can avoid using auto and declare or initialize using the explicit type, right? But also we cannot use auto, but it's not the auto that is wrong, right? But it's wrong that what is wrong is the return type is wrong. So the solution here is that we can use the explicitly type initializer idiom with auto. This way we can use auto with the type that we want. So in this example, is the same example as the previous one, except we have a phrase static cast with the type of bool. With this one, auto will return a correct type of Boolean, and we can apply these variables and so on to our other functions or other parts of the code. So now let's dive into the real code to see the example usage. The implementation of the auto and where should we aware it using auto. So the first case I want to show is when we create a function and we return a curly braces with auto. So I have this function, and yes, I'm gonna compile it to see if there's any error. You can see that we have error with line 29 here. It's line 29. So you say that cannot deduce return type from initializer list. So yes, auto cannot deduce the initializer list using the function return type. And we should be aware. So I'm gonna comment this one, and we can move to the initializing auto with the curly braces. So to see it, and we are going to see the type of it. So here we have the init list one, inside curly braces is 1, 2, and 3. And we have init list 2, inside the curly braces we have 1 and 2.0. So this statement we print the type of init list 1, and yeah, init list 2, right? So we're gonna compile it. We can see the errors again on line 60. So it's about init list 2. So we have the different type inside curly braces. One is integer, another is double. So this one auto will return the type of initializer list, but the type inside the curly braces are inconsistent. So this causing error. See it's here. So we won't. I'm gonna uncomment this one. And again. So now the compile successful. I'm gonna execute the code. So the init list type is initializer list. Right? The init list one type is initializer list as expected, right? So I just demonstrated the how we use auto with curly braces. The next one, we'll use the auto with proxy class and how should we deal with it, right? Assuming that I have the function sensor statuses, right? In the sensor status, we have the Boolean. We return the vector of Boolean. We have 4 Booleans here, true, false, true, false. And okay, I will get the encoder number 3, index number 3. So I have two variables here, sensor on 3 and sensor on 2. So the sensor on 3 will retrieve the sensor status at index 3. And sensor on 2 will retrieve the sensor status as at index 2. So you're gonna see the return type of sensor 3 and sensor 2. So here, as sensor 3, we use the temporary object of this function and use the the auto type of index 3. You can see on the output that it will return this complex type. Basically, it just show you is just the reference of the vector of encoded number 3 as in the slide. So, and the sensor on 2 will return the explicit type of bool. And no wonder this will return the bool here. So as expected, right? And so what if I have another variable sensor on 1, I do the static cast of type bool with this one. But if I want the return of sensor 1, save compiled and run. You can see here on the last line of the output. So it's the sensor on 1 return the explicit type of bool. So this is a safe way and a solution when we want to use auto with a static cast. So hope you enjoyed the video, and if you have any question, you can reach me out. Thank you so much.